Germany had every reason to trust hard engineering. Its tanks, guns, and fortifications had helped smash armies across Europe. Steel, concrete, and precision had become part of the German way of war, disciplined, organized, and frighteningly effective. So when British armour came ashore in Normandy, carrying one of the strangest weapons of the invasion, it was easy to misread it. It did not look elegant. It did not look modern. It barely looked like a proper tank gun at all. On the front of a Churchill tank sat a short, blunt Petard mortar. No long barrel, no clean silhouette. Nothing that looked graceful on a parade ground. But Britain had not built it to look impressive. Britain had built it to break concrete. This was the Churchill AVRE, the Assault Vehicle Royal Engineers. Its demolition round became known as the Flying Dustbin. And behind this ugly, practical machine stood one of Britain's most unusual armoured minds, Percy Hobart, a man the army had once pushed aside, then brought back when ordinary tanks were no longer enough. Because on D-Day, courage alone could not clear mines. Courage alone could not smash bunkers. Courage alone could not open roads through the Atlantic Wall. Britain needed something stranger, something heavier, something the enemy could underestimate only once. Friends, before we continue, please help us reach 1,000 subscribers on the channel. Subscribe, press the hype button, and tell us in the comments what you think. Now, let's continue. The Churchill AVRE does not fit neatly into the usual memory of D-Day. The usual story begins with landing craft, rough seas, young men moving through surf, machine gun fire cutting across open sand, and the desperate fight to get off the beaches. That memory is powerful. It is not false, but it is incomplete. D-Day was also a battle against objects, mines, wire, concrete, steel obstacles, seawalls, beach exits, roadblocks, strong points built to slow everything down. The Atlantic Wall was not a single wall, like a castle rampart running across Europe. It was a chain of defenses, bunkers, gun positions, trenches, mines, anti-tank obstacles, and fortified villages, all arranged to turn movement into danger. That was the point. A beach did not have to stop an army forever. It only had to delay it long enough for men and vehicles to pile up under fire. One bunker in the wrong place could hold a road. One minefield could split infantry from armour. One blocked exit could trap vehicles on the sand while the tide came in behind them. On a map, these things look small. On a beach under fire, they become everything. That was the problem Britain had to solve before June 6, 1944. Not simply how to land men, how to keep them moving. The Churchill AVRE was born from that problem. And like many British wartime solutions, it was not beautiful. It was practical, stubborn, and slightly odd to look at. A VRE stood for Assault Vehicle Royal Engineers. That name matters. This was not simply a tank with a strange weapon bolted on. It was an armoured engineering vehicle. Its job was to carry Royal Engineers into places where ordinary engineers could be cut down, pinned, or forced to work in the open while German fire came from concrete. This was not theory. Britain had learnt the lesson brutally. Before Normandy, before the invasion fleet crossed the Channel, before Hobart's strange machines became part of the D-Day plan, there had been Dieppe. On August 19, 1942, Allied forces raided the French port of Dieppe. The operation was costly and painful, especially for the Canadian troops who bore much of the fighting on the beaches. British planners studied the failure, and one lesson came back with a sharp edge. Brave men with hand tools were not enough. Engineers could be ordered to cut wire, clear obstacles, remove mines, blow gaps, and help tanks forward. But if those engineers were exposed to heavy fire, the task could collapse before it began. Courage did not make a man bulletproof. A minefield did not care how brave he was. A concrete wall did not fall because infantry needed it to fall. The lesson was cold. If engineers were needed at the front of an assault, then armour had to go with them. Not later, not after the beach was secure. At the moment of contact. So Britain began to think differently. Ordinary tanks were valuable, but they had limits. A normal tank gun could support infantry, fire high explosive shells, engage vehicles, and strike targets at distance. But D-Day was not only a fight against enemy tanks, it was a fight against obstacles, against concrete, against mined approaches, against blocked routes. That required specialist tools. This is where Percy Hobart enters the story. Hobart was not the neat, easy kind of officer that every institution enjoys. He was forceful, inventive, and sometimes difficult. He had strong ideas about armour when armies were still arguing over how tanks should be used. Earlier in the war, he had been pushed aside. By 1943, Britain needed exactly the kind of mind that could look at a defended beach and ask an uncomfortable question. What if the problem is not the men? What if the problem is the tools? Hobart was given command of the 79th Armoured Division. It became one of the strangest formations in the British Army. It did not exist to fight like a normal armoured division. It existed to develop, train with, and operate specialised armoured vehicles for the invasion of Europe. Later, these machines became known as Hobart's Funnies. The name sounds comic. The machines were not. They were tanks that could swim ashore using flotation screens and propellers. They were flail tanks that beat the ground ahead of them with chains to detonate mines. There were bridge-laying vehicles, armoured bulldozers, flamethrower tanks, vehicles that laid matting over soft ground so wheels and tracks would not bog down in sand or mud. It looked like an armoured circus. In reality, it was a toolbox for the most dangerous building site in Europe. The beach itself had been turned into a weapon. Hobart's answer was to bring tools large enough, armoured enough, and strange enough to survive contact with it. And in that toolbox, the Churchill AVRE was one of the most important. The Churchill tank was not chosen because it was sleek. It was heavy, boxy, and slow compared with some other tanks. But for this work, it had the right virtues. Thick armour, good climbing ability, decent performance over difficult ground, space for engineers and stores, a body that could be adapted. For an armoured engineering vehicle, that mattered more than elegance. The AVRE could carry fascines, bundles dropped into ditches so vehicles could cross. It could carry small bridges. It could carry demolition stores. It could support engineers working close to obstacles. And most famously, it could be armed with the Petard mortar. That was the weapon that made the vehicle look so strange. The Petard was not a normal tank gun. It was a spigot mortar designed to fire a large demolition charge at short range. Instead of the long barrel people expected from a tank, it had a squat, blunt appearance. To a soldier used to conventional guns, it could look crude, almost foolish. But the shape was not the point. The Petard was not meant to win a long-range duel. It was meant to throw heavy explosive against concrete, walls, obstacles, and fortified positions. Its round became famous under a nickname, the Flying Dustbin. It was not a delicate name. It was not meant to be. The round was large, heavy, and blunt.
The complete dustbin weighed about 40 pounds
and carried a 26-pound explosive charge. That made it very different from an ordinary tank shell. A normal shell could strike, penetrate, burst, and damage. The Flying Dustbin was closer to a demolition charge hurled from inside an armored assault. There was a price for that power: range. The Petard had to be used close to the target, close enough that the crew still had to face real danger on the approach. The AVRE was not a magic machine. It did not remove danger from the battlefield. It moved some of that danger behind armor. Picture the problem: a bunker ahead, infantry pinned, a beach exit beyond it. Artillery and naval fire may have struck the area already, but concrete can survive punishment that would tear softer targets apart. Smoke, dust, and noise fill the air. Nobody can stand in the open with demolition charges and work calmly. So the AVRE goes forward, slow, heavy, ungraceful.
The stubby Petard
Points towards a target that might otherwise require men to crawl forward on foot. Then, the Flying Dustbin goes in. This was not about beauty. It was about making the impossible slightly more possible. That is why the Churchill AVRE matters. It shows the difference between romantic history and real war. Romantic history remembers flags, speeches, and brave charges. Real war asks, who clears the minefield? Who opens the exit? Who gets a bridge across the ditch? Who breaks the wall? Who moves the next vehicle forward before the entire landing clogs into chaos? The British answer was not one machine, it was a system. That is the part of D-Day people often miss. The British and Canadian beaches were not supported by Hobart's Funnies because somebody wanted a novelty show. They were supported by specialized armor because planners had identified specific problems and built specific answers. At Gold, Juno and Sword, British and Canadian forces still faced mines, obstacles, strong points, and German fire. These were not easy beaches. Men still died. Vehicles were still hit. Plans still broke down. Weather, confusion, smoke, and resistance shaped the morning. The Funnies did not make D-Day clean, nothing could, but they helped solve particular problems at the moment those problems mattered most. A flail tank could begin clearing a lane through mines. A bridge layer could help cross a gap. An armored bulldozer could push aside obstacles. An AVRE could attack a bunker, wall, or roadblock with demolition fire. This is why the nickname Funnies can mislead. It makes the vehicles sound like eccentric toys. They were not jokes. They were the physical result of painful lessons learnt before Normandy. The Churchill AVRE was one of the clearest examples. It looked strange because the task was strange.
A normal battlefield
asks tanks to fight tanks, support infantry, and exploit movement. Normandy asked tanks to become engineers. That is a different kind of war. Slower, dirtier, more mechanical. Less about a glorious charge, more about opening a path through a killing zone, one ugly problem at a time. Here, the British story becomes more interesting than the myth. The myth says, Britain won respect through stubborn courage alone. There was courage, plenty of it, but courage by itself is not a plan. Britain's strength in this part of D-Day was adaptation. It was the ability to look at failure, especially Dieppe, and build tools that admitted the truth. Men on foot could not be asked to do every job under fire. That admission saved lives. Not all lives. War never works so neatly, but enough to matter. There is also an uncomfortable comparison along the Normandy coast. At Omaha Beach, American troops faced one of the worst mornings of D-Day. The terrain was brutal. The beach was exposed. German positions had dangerous fields of fire. Bombing had not neutralized the defenses as hoped. Many amphibious tanks launched offshore did not reach the beach. Infantry had to cross deadly open ground, while units became mixed, officers were lost, and plans broke apart under fire. Omaha became the costliest of the D-Day beaches. That has left a hard question in the memory of the invasion. Would more specialized armor have helped? The answer has to be careful. It is tempting to say yes with anger and certainty. British machines helped on British and Canadian beaches, so more of them must have changed Omaha. Perhaps they would have helped. But history is not improved by turning tragedy into a simple verdict. Omaha was not caused by one decision. It was shaped by terrain, weather, German defense, bombardment problems, tank losses, command disruption, and terrible exposure on the beach. The limited use of the full range of specialized armor was one debated factor, not the whole explanation. Still, it remains an uncomfortable factor, because the British had built tools for exactly the sort of problems defended beaches could produce. Mines, obstacles, exits, concrete, strong points, blocked movement. American forces did use some specialized equipment, including DD tanks, but they did not land with the same full suite of Hobart's Funnies that supported the British and Canadian sectors. That difference matters, not because it proves one army wise and another foolish. That is too crude. It matters because equipment choices can become human consequences. On paper, a specialized vehicle is a technical detail. On a beach, it can decide whether a path opens now or later, and sometimes later is paid for in blood. This is why the Churchill AVRE deserves more attention than it usually receives. It was not the most famous tank of the war. It was not the fastest.
It was not the most elegant.
It did not become a clean national symbol like the Spitfire. No poster maker would choose it as the face of technological beauty. But it carried a hard British lesson. Do not fight the war you wish you had. Fight the obstacle in front of you. That was Hobart's genius. Not that every idea was perfect, not that every machine worked flawlessly, not that specialized armor removed the chaos of battle. It did not. The genius was in recognizing that the invasion of Europe was not simply an infantry landing, not simply a naval operation, not simply an air campaign, and not simply an armored assault. It was an engineering problem at continental scale. Beaches had to be crossed, mines had to be cleared, roads had to be opened, ditches had to be bridged, concrete had to be broken, and all of it had to happen while the enemy was firing. That is the real meaning of Hobart's Funnies. They were not funny because war was funny.
They were funny
because the problems were so specific that the solutions looked bizarre. A tank with chains thrashing the ground. A tank carrying a bridge. A tank that could swim. A tank with a flamethrower. A Churchill with a blunt mortar firing something called a flying dustbin. Seen separately, they looked absurd. Seen together, they were a language. Britain was saying that the next assault would not repeat old mistakes if machines could prevent it. The AVRE spoke that language in concrete and blast. Its crews still had to get close. Its engineers still faced danger. Its weapon still had limits. The Petard could be awkward. Reloading exposed part of the process to danger. The range was short. The vehicle had to survive the approach. The crew had to judge distance and target under battlefield pressure. This was not a wonder weapon. That phrase belongs in comic books. The AVRE was something more serious. A useful weapon. Useful is not a small word in war.
Useful means
A man might not have to crawl forward with explosives while bullets cut the air. Useful means a blocked exit might open before the tide and traffic make the beach a trap. Useful means a bunker that has survived bombardment might finally be dealt with by a weapon designed for that exact job. There is a quiet brutality in that kind of usefulness. The flying dustbin was not elegant. It was a blunt answer to a blunt problem. The Germans had spent years building hardened positions across occupied Europe. They understood concrete. They understood fields of fire. They understood that even a delayed enemy could become a destroyed enemy. Britain answered not with a prettier tank, but with a stranger one. And that is why this story cuts through the usual picture of D-Day. Germany could trust the serious shapes of proper guns, heavy bunkers, and established military design. From that point of view, the Petard looked almost ridiculous.
but a bunker
Does not care whether the weapon approaching it looks ridiculous. It cares what happens when the charge hits. On June 6, 1944, British and Canadian troops did not cross Normandy because of one machine. No single tank carried D-Day on its back. The invasion required ships, aircraft, landing craft, infantry, engineers, command, logistics, deception, planning, and sacrifice on a scale almost impossible to hold in the mind. But inside that vast machine of invasion, the Churchill AVRE did something specific. It helped turn engineering into assault. It brought demolition power forward under armour. It gave engineers a better chance against obstacles designed to freeze men in the open. That is enough to make it important. After Normandy, AVREs continued to serve in Northwest Europe. The war did not suddenly become easy after the beaches. German resistance remained fierce. Towns, rivers, fortified positions, and obstacles created new problems. Armoured engineers remain necessary because armies do not advance by courage and firepower alone. They advance by solving the ground beneath them. A road must be cleared. A bridge must be crossed. A wall must be breached. A mine must be found before a boot or track finds it first. The Churchill AVRE belonged to that world, the unglamorous world where progress is measured in gaps opened, routes cleared, and obstacles removed. That is why British wartime engineering deserves more respect. The great symbols matter. The Spitfire matters, the Royal Navy matters, the speeches matter. The endurance of civilians under bombing matters. The soldiers who fought in North Africa, Italy, Burma, and Normandy matter. But the strange machines matter too, because they show Britain not only enduring the war, but learning inside it. That is sometimes the harder kind of strength. Not the strength to pretend a disaster never happened, the strength to study it, to admit what failed, to build something ugly enough to fix it. Dieppe had shown that exposed engineers could be trapped and stopped. Normandy showed a different answer. Engineers protected by armour, machines built for mines and obstacles, and a division organized around the idea that the battlefield could be solved one practical problem at a time. There is no need to inflate that into legend. The facts are strong enough. The AVRE was not a joke. The Petard was not a design mistake. The flying dustbin was not a cartoon weapon. It was a demolition charge sent forward by a country that had learnt, painfully, that concrete does not fall to bravery alone. And now the opening image returns. A Churchill tank on a beach, a short, blunt mortar where a long gun should be. A machine that looks wrong until you understand the job. It was not built to impress the eye, it was built to change the situation in front of it.
That is a very British kind of weapon.
Awkward, practical, unsentimental, and far more dangerous than it first appears. Germany could mock the shape. The concrete felt the answer. And when the Atlantic Wall met Britain's strangest gun, the joke did not last long. If you want more British WW2 stories with the myths stripped back and the evidence kept in view, subscribe to Defiant Britain WW2 and help us reach 1,000 subscribers. Tell us in the comments which strange British wartime machine we should cover next. Because some of the most important weapons in history were not the ones that looked powerful. They were the ones that solved the problem nobody else wanted to face.